Welcome to the live lesson on FBF3 from Unit 4. What FBF3 stands for is it's things that happened to a function. So if we had, I'm going to break this down what this says. If we had some function f of x, then we do stuff to it. And let me show you what I mean by stuff. So just in this little paragraph thing that they have here. So you can add k onto f at the end. You can multiply the whole f of x by k, or you can multiply just the x inside the f of x by k, or you can add k to just the x. So all four of those things do four different types of transformations to a function. So first, you need to know that what we'll have with all functions is we have one main parent function. In this particular lesson, we're only dealing with functions, the functions f of x, like x squared, x cubed, and x to the fourth. But these rules go for every function. So we could have linear ones, we could have exponential functions follow these same things, logarithmic. I don't know if you remember talking about exponential and logarithmic functions. They all follow these same things. So it's kind of cool. I think it's cool anyway. So first we're going to start with the parent functions. And I call this part one, shift happens, because we're talking about shifts. Whether that's a horizontal shift or a vertical shift, it just is all there. So we have our parent functions. X squared, you might remember that this thing right here is called a parabola. Oops, wrong color. Parabola. This is a cubic. There's not a fancy name for that. I joke around that it's like a disco thing that's pointing up and down. Then we have f of x equals x to the fourth. Notice that they kind of like x squared, kind of like x to the fourth, right? But it's kind of wider right here. In fact, if we were to go to decimals, let me just show you really fast here. If we go to decimals, here's x to the fourth. It's like wide at the bottom, but if I compare that to x squared, did not turn out anything like I wanted it to. Try this again. Squared. Okay. So the squared is the blue one. So it's like kind of more pointy at the end and wide at the top, while this x to the fourth is more wide at the bottom and narrow at the top. Okay, so they kind of look the same. In fact, let me just teach you a thing that's not technically part of this lesson or this assessment, but it is part of the standard. This standard, so the top line is really all we're talking about with these things, but what this whole standard has to do with also is talking about even or odd functions. So let me just briefly talk about that. Even functions are functions like this whose power is an even number and they both point up or they both point down. While odd functions are functions whose power is an odd number and one side goes down and one side goes up. Whether they're both up, like one left side's up, right side's down, or right side's down and left side's up. They're going to go opposites. So odd goes on the opposite sides and even goes on the same direction. So these are the base. This is the base function, the parent function. And then everything else from there is stuff that you would do to it. So this g of x that I'm giving as my first example, g of x is we say we took this x squared and we added 2 to it. Literally what that graph would do is it would just look like the exact same thing. It would just start up 2 higher than it was. So this went up 2. Pretty easy. So that is when what you're adding, or if you're subtracting, it's going to go down, right? It's on the outside. It's not inside the parentheses. It's outside of the parentheses. On the other hand, if we had something like this next one, where there's inside the parentheses, then we added something to it. Okay, so you know that when we're talking positive, negative, this is the positive direction, negative direction, positive direction, negative direction. Same here. Positive, positive, negative, negative. But when we're doing stuff that's on the inside of the parentheses, it's something that I call, for the sake of helping my brain remember, it's the opposite. It's insider's lie is how I call it. So inside because it's the opposite. So we'd want to say it's going to go in the positive direction too, but that's the lie. It's going to go left too, and it will look like the exact same thing. It's just going to be moved over left too. So this is going to be left 2 units. So if it's on the inside of the parentheses, oops, if it's on the inside of the parentheses, it's an insider's lie, and it goes the opposite of the plus direction. It's going to be left 2. Then this one, this j of x equals x to the 4th, subtract 2. So this is not on the inside. It's at the end. It's subtract 2. So it's literally going to go down 2, and then look like almost the exact same thing, just down 2. So down 2. So based on what I said specifically about this h of x, what would you guys guess? What would you two guess is going to happen with this one if we had x minus 2 subtract 2 on the inside of the parentheses? What do you think is going to happen? If when we added 2, it went left 2, what do you think is going to happen if we subtract 2 on the inside of the parentheses? So inside the parentheses, I added 2, and it went left 2. So if on the inside the parentheses, I subtract 2, where do you think it's going to go? Yes. So instead, it will start over here, right 2, and it will be like this. Whoops, that's really not a very good graph, but pretend like it is. Okay, so it is indeed going to go right 2, and that's it. So let's just summarize this. If you're adding or subtracting at the end of everything, so it's not on the inside, so no parentheses, not on the parentheses. If we add a number, that's going to go up. If we subtract a number, that's going to go down. So up k, down k. If it's on the inside and you're adding k, that's going to go left k, and then this one's going to go right k. So we looked at the graphs, and it literally does just move it up or down or left or right. So that's like all it does when you're looking at the graphs. They, on these problems on the quiz or on the assessment, it's literally going to be 2 graphs and the same thing, and they're going to label it. Like they will say that this one is k of x and that the other one was f of x. They'll label them. So that one was the f of x, and then this was the g of x. So you'll be able to tell according to the labels what it looks like. Other examples with these other so then they have the other graphs are just going to be, the other examples are non-graph examples. So you'll notice these problems have everything the same here. So all these, like this part is the same. And then all you're looking at is the last little part here. What was the difference between going from 3 to 4? What would we have to go do to go from 3 to 4? Okay, so then to get from 3 to 4, so you're just looking at, and think of it as like a normal number line. If I was up at 3 and I went down to 4, can you see how I would subtract 7? You guys agree that you would just subtract 7 to get from 3 down to 4? So we would literally say, and then subtract 7, that's down, right? Because it was at the very end. And so we would just say it shifted it down 7. Down 7. And so we can put shifted it down 7. Okay, so then let's look at this next one. Going from negative, so all this stuff is the same, right? So from -1 to 8, what did we have to do to get from -1 to 8? On this last one, we subtracted 7, right? Because 3 subtract 7 was -4. So then -1, and then what do we have to do to -1 to get to positive 8. Added it. Add how many? Look at both of you go. So it wouldn't be 7. Yes. Okay. So because if we did -1 plus 9, and let me just show you another way of looking at that. 9 subtract 1 is 8. Because notice we have a positive 9 and a -1. So we would add 9. So we'd say shift up 9. And that's it. I know I do things like that all the time, especially if the teacher's asking me. My brain, like, I could do it fine on my own, but if the teacher asks me, my brain goes kaputty and then I forget. Okay, so then F these next ones. Notice that the change, we still had like all of this stayed the same. They both had subtract 2, so it's not going to be up or down. The only difference was they added parentheses and they did stuff inside the parentheses. So let's go back up here. When we had parentheses, it needs to be the opposite of whatever was right here. So plus means it goes left. So what would this one do? What would this x plus 5 do? So right here I put left k because that was the number. Right here we had this plus 2 meant it went left 2. So right here, if I have a plus 5, what would it go? It would be left 5. Because normally the x-axis, like this is plus, so normally you would go positive 5, but because it's the horizontal one, and horizontal, we said that insiders lie, we have to do the opposite of the positive direction, which is the negative direction, and that's why we would say left 5. So with this one saying subtract 3, what would that be instead? It'd be shift what? Yes, right. 3. Nice work. All right. All right, so that's this up, down, left, right. So that's half of the lesson. And the other half has to do with dilations, which dilations are stretches or compressions. And on this particular quiz, they don't graph them. They just look at examples. Just for showing you what it looks like, let me show you. In fact, let me show you this. So if we had x to the third, let me change this to x to the third. I'm going to take this one away. X to the third, subtract 8. Let me zoom out so we can see it. So there's x to the third, subtract 8. And now I had 2x to the third, subtract 8. It's almost the same thing, but this is what I picture. I picture somebody grabbing the ends of the red one and then like stretching it, pulling it away from the x-axis. So that would be, so then let's come back to our thing. So we want to know, okay, it says toward, it'd be toward or away from the x-axis. And I always call it a vertical stretch, and everybody else in the world calls it a vertical stretch, but Strong Mind calls it toward the x-axis. So notice between this x cubed, subtract 8, that what I would have to do, and so this is a big thing that you have to notice. It's kind of like I took this entire thing and multiplied it by 2 to get that, right? Because 2 times by x to the third is 2x to the third. And then 2 times -8 is -16. In fact, did we do that on this thing? Forgot to do 16. 16. Okay. They took the whole thing and it stretched it all the way out. So that's important. I forgot to include that. But that is called, so how I would say it is I would say a vertical stretch by a factor of 2 because we multiplied it by 2. But what we'll say is, because this is how Strong Mind puts it. And I want to make sure that you get the same wording as Strong Mind so that when you're doing it, you're not going to be confused because it's multiple choice. And I think it could be very confusing. So let me make sure I get the exact wording correct. So hold on while I make sure we have the exact wording. Okay, it is. Okay, so we multiplied it. We multiplied the entire thing by the same number. And so we say the graph is stretched. Stretched. I should put away from, toward or away from the x-axis by a factor of 2. Because it was on the outside and we multiplied everything by that. This looks a little bit confusing. I'm going to write this again. It was the 2x cubed subtract 16. Because we multiplied everything by 2 to get that. So that was by a factor of 2. So that was stretched away from the x-axis by a factor of 2. All right, and let's just do the next one underneath it because it's also vertical. If you guys have any questions, please stop me. If I needed to go from f of x down to g of x, what would I have to do to get from 6? It'd have to be the same thing to get from 16 to 4. What would I do, like dividing or multiplying wise, to get from 16 to 4 and from 12 to 3? Can you see what I would do to both of them? Yeah, you would divide. Perfect. What would you divide by? Nice, Hannah. So you would divide by 4 to get that one. And so then this would be a factor of 1/4. So when you divide by 4, we just put that number over 1. So it'd be a factor of 1/4. So we would say graph is being, now this is where if it's a fraction like that, the word is compression. So if that number is between 0 and 1, in other words, if it's a fraction, then we'd say it's being compressed. Let me come up here so we can see compressed. Toward the x-axis by a factor of 1/4. Being compressed toward the x-axis by a factor of 1/4. The next part that we're going to talk about is related. It's now just doing the horizontal stuff. And so the horizontal stuff, the main thing that it's different because it's almost the exact same thing, but as far as like a stretch or compression. However, notice that a stretch on the vertical one is when your K that you're talking about is something bigger than 1. And I technically should put the absolute value because if there's a negative, it reflects it, but we don't really do that with these. And I should put an absolute value here. If instead a horizontal stretch, which is going, the stretch is going to go toward the x. Let me see. Let's put this. A stretch is going away from the x-axis, and the compression is going toward the x-axis. While this, the horizontal stretch, is going to go away from the y-axis, and a compression is going to go toward the y-axis. And it's so that, and then they kind of switch places because on the stretch before was when K was greater than 1, but now it's the compression. So it's again that like insider's lie when there's parentheses. Remember that it's going to be kind of the opposite of what you think it should be. And to tell the difference, and this is kind of big, is are you multiplying the whole function by the same number or just the x? And in fact, I'm going to put just the x. The hint for that is the parentheses. So on this example that we have here, we have subtract 5 on both of them. It was not multiplied by something, but the x inside the parentheses was, and so then we know that we're dealing with the horizontal stuff, which is according to the y-axis. So we have x-axis is the vertical one, y-axis is the horizontal one. And since it was 2, so let me just go in here and write the things that we did for it. I'm going to put x, multiply x by 2. That's going to be a compression. Graph is compressed toward the x-axis. Y-axis, excuse me. Y-axis by, and you're ready for this, 1/2. Because though we multiplied by 2, that means it's going to become 1/2. Weird, right? It's like the opposite of what it was on the other one. And then this next one's kind of the same type of thing. Notice we would have to divide by 3 here. So that would mean it would be 3. So it's going to be a factor of 2 by a factor. I should put here, I forgot it, a factor of 1/2. Of 1/2. And then this one, the graph is stretched away from the y-axis by a factor of 3. Weird, right? It's kind of like all sorts of weird. So what I would recommend for you when you're doing this part, because it's not going to give any graphs, what I would recommend doing is looking at these notes. So I will have these notes will be found along with the recording of this video in the resources tab of the class. And then the notes are going to be just right underneath the video. So the recording will be there in probably like an hour. And then the notes will be right underneath that. And then I would recommend using these notes to take the test because you can use these notes to take the test or the assessment. Any questions on other things while we're here? Okay, Hannah? All right. Thank you so much for attending, both of you, and for participating. That was awesome. Have a wonderful rest of your day.